Hi, I'm Mike Malone, founder and CEO of Smallstep. My background is software engineering. I have spent my career working on large scale distributed systems, open source and standards, particularly around identity based security. I've worked on OAuth, OpenID, SPIFFE, Sigstore, and a new protocol called Acme device attestation that I'll be talking more about today. Small Steps Core Technology is a certificate management toolkit. We're open for, so that core tech is open source and it's widely deployed to secure software systems from home labs up to some of the largest corporations in the world. Today, I'm going to be talking about device identity, which is our commercial focus. We started working on new standards for device identity about 4 years ago and began deploying commercial device identity solutions about 2 years ago. In that time, we've worked closely with some of the largest and most security conscious companies in the world. These companies take device identity very seriously, but many of the lessons they've learned translate to organizations of all sizes. So today, I'm going to share some of what we've learned from them with you guys. So let's start with the definition. The goal of device identity is to ensure that only trusted devices can access sensitive resources. This is a fundamental security primitive. Just as user identity enables restricting access to employees and other trusted people, device identity enables restricting access to company-owned hardware and other trusted hardware. And when I say trusted devices, that usually includes the laptops that you give to your employees when you hire them, but it might also include contractors using Chrome OS devices, dedicated devices like point of sales terminals, and your CEO's iPhone. And when I say sensitive resources, I mean internal and SaaS web apps, office Wi-Fi, SSH access to VMs, remote access via VPNs and CTNAs, developer access to GCP and AWS APIs, access to shared files and Dropbox and Google Drive, and the list goes on. So like user identity, it's important to have a simple and consistent identity fabric for all of these devices and resource types. Why is it important? Well, first, device identity improves security and usability if you do it right. Restricting access to trusted devices prevents exciting threats, either accidental or malicious. So it prevents employees from pushing code to GitHub from Plex Media Center or accessing sensitive customer support dashboards from your friend's computer, for example. Tailscale recently released a zero trust report that found that 32% of professionals admit to working on personal devices, and 68% retained access to systems after leaving a previous employment. Good hygiene around device identity mitigates these risks. More importantly, most cyber attacks today hinge on credential exfiltration, not on exploit. If you can restrict access to trusted devices, an attacker cannot exfiltrate credentials and use them from an untrustable device. This mitigates a ton of attack vectors and improves your ability to detect and respond to any breaches that do occur. Even better, since devices can identify themselves, device identity is invisible to end users. This allows for seamless access to Wi-Fi, for example. And if you do it right, device identity is NIST AAL3 compliant MFA. So it stops phishing without a security certificate. This is awesome for a lot of use cases. One example we see a lot of is SSH, where device identity can replace solutions like Cisco Duo that have particularly annoying end user workflows. One of our customers reports 0 account takeovers in 3 years after implementing device identity, and all of this without end user impact. So it's rare to get this sort of security win while improving user experience. Finally, device identity is proven valuable for securing agentic AI, obviously a popular topic. AI agents are using OAuth tokens to authenticate to XML servers. The number of bearer token credentials is growing rapidly, and scope of access is increasing. Device identity can tie tokens to physical hardware, which prevents token exfiltration attacks. This completely eliminates the biggest security challenges related to OAuth and OIDC, that is, secure management of all of these bearer tokens. So again, if a bearer token can only be used by specific trusted devices, they're no longer a security concern. They can literally commit an access token to a public Git repo, and you can't do anything with it. So to summarize these benefits, I've got a couple quotes pulled directly from the project descriptions at two big tech companies. I can't say who they are, but they're both companies you've heard of. So tech company one says, knowing with certainty that only trusted devices can access sensitive networks, apps, and resources mitigates phishing without impacting end user workflows and strengthens our defense against credential theft. And tech company two says, without hardware-bound device identity, HDDI, attackers can easily exploit weaknesses in mimic trusted devices, leading to breaches. With HDDI, the only viable attack path remaining would be for attackers to actively proxy through trusted devices. This approach is exceedingly challenging and increases our chances of protection compared to attackers using credentials or remote hosts that we cannot monitor. So, if you do it right, device identity is a valuable cornerstone for a cybersecurity program. Unfortunately, one more thing that these tech companies know is that almost nobody does device identity right. Starting at the foundation, the default for enrolling devices into management and issuing a certificate for device identity today is a protocol called SCEP, Simple Certificate Enrollment Protocol. SCEP is a dumpster fire. It is fundamentally broken because it relies on passwords. Microsoft's variant called NDES is literally screen scraping HTML2 websites. These protocols were designed in the late 90s when PCs were unboxed by IT support staff in a physical office and onboarded manually before being installed in an employee's office, right? So things have changed a bit since then, but these protocols have not. Another anti-pattern that's gradually common is self-reported device identity. That means some agent running on the device calls an API or includes a device serial number in an HTTP request. But this isn't actually authentication. It's a username without a password. So in security theater, that's really trivial to bikers. So how do you do device identity right? Devices should be cryptographically authenticated, and credentials should be hardware-bound in a TPM or secure enclave to prevent exfiltration. Exfiltrating these credentials requires destructive disassembly in a LAN. So using non-exfiltratable hardware identity for devices is critical to see the full value of device identity. But another thing the tech titans know is that doing device identity right is hard. You need an inventory of trusted devices. You need to get hardware-bound certificates on all those devices. Yeah. You need contingency plans for legacy hardware. You need to integrate with CTNA, VPN, Wi-Fi, radius, SSH, a lot of APIs. You need to configure browsers and other clients, workflows for BYO, dedicated devices, unmanaged devices, contractor devices. You need to do this for every operating system, Mac, Windows, Linux, Windows, iOS, Android. You need to audit support tool, and you need audit and support tooling for at-scale operations. Independent estimates for people who have built all of this put the cost at a minimum of $2 million plus $500,000 a year to maintain just for core requirements. This is a problem we're addressing also. So starting at the foundation, we've worked with Google and the IETF to create a new standard that replaces SCEP. It's called Acme Device Attestation. That work started in 2021. And at WWDC in 2022, Apple announced native support for Acme Device Attestation. So it's natively supported on billions of devices. On non-Apple platforms, you can use the standard trusted platform modules, or TDMs, to do Acme Device Attestation user space. So this new protocol works everywhere, using Smallstep's user space endpoint too. Instead of a password, Acme Device Attestation authenticates devices using a private key generated in TPM or secure enclave and manufactured. So this is hardware-attested, hardware-bound identity. In other words, it's really secure. Apple calls it the quote, strongest possible guarantee. So building on our cross-OS support for Acme Device Attestation, Smallstep's device identity platform includes APIs, MDM and OEM integrations to build trusted inventories automatically, turnkey integrations with CTNAs, VPNs, NACs, SSH, and more, automated configuration of browsers and other clients, workflows for BYO, contractor, dedicated and unmanaged devices, backwards compatibility with SCEP and NDES for legacy hardware, and all that audit support tooling we use for at-scale operations. We're already working with some of the biggest companies in the world, and we're very excited to be working with Jamf to make our technology available to all Jamf Pro users. We're starting by improving device enrollment and providing certificate-based Wi-Fi, which are 2 use cases that everybody has. Just lost my notes. Oh, there. For enrollment, when you buy a laptop, it leaves the factory with a hardware-bound private key in the secure home layer. Jamf will tell us that you bought a new device and sync over the device metadata to a trusted device inventory for high assurance enrollment. Via this integration, devices can cryptographically identify themselves as soon as they leave the factory. That means you can drop ship a laptop to a remote employee and it can automatically identify and enroll itself, cutting IT overhead and improving end user out of box experience. This is the golden path. Like I said, we're already doing this with some customers. We're excited to be working with Jamf to bring this to all Jamf Pro users. We're also working with Jamf to make certificate-based Wi-Fi turnkey easy for all Jamf Pro users. Again, we offer all the pieces necessary here. We handle with certificate management. We have hosted radius as well as integrations with Macs like ClearPass, JNUC, with device, and our endpoint agent can configure ETLS on all platforms, even Linux. So our platform already supports Wi-Fi deploys for hundreds of thousands of devices, and it only takes a few minutes to set up. Our goal is to make it easy for all Jamf users to adopt best practices for high assurance device identity for all use cases. At Smallstep, we do device identity. Thank you for having me today, and please stop by our booth.